So in this video, I'm going to show you how to solve some other types of equations. Some of them look kind of like quadratic, so we'll use the methods that we learned when solving quadratic equations. Some of them do not look like quadratics, but we can still use some of those methods. So I think we should just get started with this first one here. I have x to the fourth plus 3x squared minus 28 equals 0. And I'm going to notice something. I want to notice that x to the fourth is the same as x squared squared, okay? So I've got this thing here, and then I've got the same thing squared, right? So if I rewrite this equation, I can rewrite it as x squared squared plus 3x squared minus 28 equals 0. And this, if I ignore what's going on in the things here, and I just pretend that this is like x, this looks like a quadratic. So what I'll do is I will do what's called a variable substitution. So I will let u equal x squared, and I can rewrite this equation here in terms of u. So if my u is x squared, then I just replace everything where x squared is with u. And this equation becomes u squared plus 3u minus 28 equals 0. And now this is just a quadratic equation that I know how to solve using a bunch of different methods, but me personally, I'll use target product, target sum. I want factors of negative 28 that add to 3. So my factors of negative 28, we got what? 2 and negative 14. We got 4 and negative 7. We got negative 4 and positive 7. And then 2 minus 14, their sum is negative 12. 4 minus 7 is negative 3. Negative 4 plus 7 is 3. So now this 3 matches this 3, so I use these two as my factors. And because a is 1, I can just rewrite this in terms of its factors. So the factored form of this is u minus 4 times u plus 7 equals 0. Now I set these separately equal to 0 by the zero product property. So I have u minus 4 equals 0 and u plus 7 equals 0. If this solution method is unfamiliar to you, I recommend that you check out my video on solving quadratic equations. I go over all this in a little bit more detail. So now I can just solve these equations for u. Subtracting 4 from both sides here, I get that u is equal to positive 4. Sorry, adding 4. And then subtracting 7 from both sides here, I get that u is equal to minus 7. But remember, at the beginning, I said that u is equal to x squared. And we're solving this equation for values of x. So I need to plug x squared back in for u. So remember that u is x squared. So x squared equals 4, and x squared equals minus 7. Okay? X squared equals 4, I can take the square root of both sides, and I get that x is equal to plus or minus 2. And then over here, I have x is equal to plus or minus the square root of negative 7. And then remember that the square root of a negative number is just I times the square root of that number. So this is x equals plus or minus I times the square root of 7. And if you're unfamiliar with that, I recommend checking my video on complex numbers. Okay, so my solutions to this quadratic equation, it has degree 4, are x equals positive 2, negative 2, positive I root 7, and negative I square root 7. Okay. Okay, moving on. I have 6x plus the square root of x equals negative 1. I'm going to go ahead and rewrite this in a nicer form. So I'll add 1 to both sides, and that gives me 6x plus the square root of x plus 1 equals 0. Okay, And now I'm going to notice something. I'm going to notice that the square root of x squared is equal to x, right? So then I can rewrite this equation as 6 times the square root of x squared plus the square root of x plus 1 equals 0. And again, I notice that if I kind of ignore what's in the parentheses here, this looks like a quadratic equation. So I will do a variable substitution, and I'll let u equal the square root of x. Rewriting this equation in terms of u, I have 6u squared plus u plus 1. So just everywhere where there was a square root of x, I just replaced it with u because u is square root of x. And that's equal to 0. Okay, and now I can solve this by grouping. So I want factors of a times c, which is 6 times 1. So I want factors of 6 that add to 1. So I have factors of 6 are 6 and 1, 2 and 3, and that's kind of it, right? So it looks like I don't have any nice factors that I can use here, so I'll need to use the quadratic equation, okay? So remember that the quadratic equation is, in this case, we're solving for u. So u is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And if you're unfamiliar with that, I would recommend checking out my video on the quadratic formula. All of these videos that I'm mentioning, by the way, are in the college algebra playlist. So go check that out if you're curious. So my a is 6, my b is 1, and my c is 1. So u will equal negative 1 plus or minus the square root of b squared, which is 1, minus 4 times a is 6, and c is 1, over 2a. And in this case, a is 6, so I have 2 times 6, which is 12. So this tells me that u is equal to negative 1 plus or minus the square root. Okay, 4 times 6 is 24, so 1 minus 24 is negative 23 over 12. So u is equal to negative 1 plus or minus, remember the square root of a negative number is I times the square root of that number, so I times square root of 23 over 12. Now remember, we're solving things in terms of x, and I let u be the square root of x. So I need to substitute that back in down here. And I have that the square root of x is equal to negative 1 plus or minus I square root of 23 over 12. Now to solve for x, I need to square both sides. And so I get x is equal to negative 1 plus or minus I times the square root of 23 over 12 squared. Okay, so I'm going to go ahead and bring things over here. So we have that, I'll rewrite this, x is equal to negative 1 plus or minus I square root 23 over 12 squared. So x is equal to negative 1 plus I square root 23 over 12 squared. And x is equal to negative 1 minus I square root 23 over 12 squared. Okay, so solving these out here, I get that x is equal to, if you remember the formula, let's use this here, I'll write it up here. So a plus b squared is equal to a squared plus 2ab plus b squared. And I challenge you to verify that by FOILing a plus b out. Okay, so this will give me my a in this case will be negative 1 over 12, and my b will be I, the square root of 23 over 12. This is the same here. So my x is equal to a squared, which is negative 1/12 squared, which is 1 over 144, plus 2ab, so plus 2 times negative 1 over 12, times b, which is I square root 23 over 12, and then, let's see, plus b squared. So I times the square root of 23 over 12, this is I squared times the square root of 23 squared over 144. Remember that I squared is the same as negative 1, so let's just go ahead and rewrite all of this as 144 minus 2 times I, the square root of 23 over 144, minus, because this I squared is minus 1, the square root of 23 squared is 23 over 144. So because all of these have a common denominator, I can just go ahead and add up all these fractions, and I get that this is going to be minus 22 minus 2I, the square root of 23 over 144. And if you want to make things pretty, I can take a 2 out and get that x is equal to negative 11 minus I square root of 23 over 144 divided 2 is going to be 72. Okay. A lot of work, but that's what our solution is for that first one. And I challenge you to verify that the other x is equal to negative 11 plus I times the square root of 23 over 72. Okay, but those are my two solutions for this equation here. Okay, now moving on, I have 1 over x squared plus 1 over x minus 1 equals 0. So again, I want you to notice that 1 over x squared is the same as 1 over x squared. So I can rewrite this equation as 1 over x squared plus 1 over x minus 1 equals 0. And I'm sure you're noticing a pattern. I can just let u equal 1 over x. Then I can rewrite this equation as u squared plus u minus 1 equals 0. Okay. Now, just like in the previous example, there's no nice factors of negative 1 that add to 1, so I'm going to have to use the quadratic formula. So I have that u will equal negative b plus or minus the square root of b squared minus 4ac over 2a. And that is the same as saying my a is 1, my b is 1, and my c is negative 1. So I have negative 1 plus or minus the square root of b squared is 1 minus 4 times a is 1 times c is negative 1 over 2 times a is 2 times 1, which is 2. So I have that u is equal to negative 1 plus or minus the square root. This negative and this negative will cancel out, so I'll get a positive 4, and I have the square root of 5 over 2. Okay. Now, remember that u is 1 over x, so I need to make that substitution back. So I have that 1 over x is equal to negative 1 plus or minus the square root of 5 over 2. Now, what I can do is I can take the reciprocal of both sides, and what I mean by that is I can just flip this fraction here and flip this fraction here. Okay, so that gives me that x is equal to 2 over negative 1 plus or minus the square root of 5. Okay, cool, but we're not quite done because that radical in the denominator looks pretty ugly. So I will split this up into the two cases that we have. We have that x is equal to 2 over negative 1 plus the square root of 5, and I have that x is equal to 2 over 1 minus the square root of 5. Now, what I'm going to do to rationalize this denominator is multiply by what's called the conjugate of negative 1 plus the square root of 5. And all that is -1 minus the square root of 5. And what I'm doing there is taking advantage of the fact that, I'll write it up here, a plus b times a minus b is a squared minus b squared. It's a difference of squares, right? So applying that to this, in the denominator, I'll have that x is equal to 2 times -1 minus root 5 over -1 squared is +1 minus the square root of 5 squared is 5, so I have 5. Now this becomes x equals -2 minus 2 roots of 5 over 1 minus 5 is -4, which is the same as 1 plus the square root of 5 over 2. Okay? Now I challenge you to verify that solving this out in the same way will give you that x is equal to 1 minus the square root of 5 over 2. So this tells me that my answers are x equals 1 plus or minus the square root of 5 over 2. Cool. Okay. Now moving on, I'm going to show you one that requires a little bit of a different strategy. So I have x cubed plus 2x squared plus 5x plus 10 equals 0. And what I'm going to do is try and split this right down the middle. Now the reason I do that is because over here, I notice that I can factor out an x squared, right? Because I have x cubed, so x cubed factoring out x squared is x. Factoring out x squared from 2x squared is going to give me 2. And writing this factor out here, like I did when I was solving quadratics, again, if you're confused, I would say go watch that video. I can factor out a 5 from this to match this. So if I factor out a 5, I have x plus 2. So my two factors are this plus this, so x squared plus 5, times these factors here, x plus 2 equals 0. And those are my two factors. Now, by the zero product property, I can set these both equal to 0. So this is x squared plus 5 equals 0, and this is x plus 2 equals 0. So I have that subtracting 5 from both sides over here, x squared equals -5. I can take the square root of both sides and get that x is equal to plus or minus the square root of -5. Remember that the square root of a negative number is I times the square root of that number, so I have plus or minus I, the square root of 5. Over here, I can subtract 2 from both sides, and x is equal to -2. So all my solutions are x equals -2, x equals I times the square root of 5, and x equals -I times the square root of 5. Okay? So those are kind of the methods that we can use to solve other types of equations if we notice that they look like quadratics, or they look like something we can factor by grouping here. And yeah, that kind of wraps up what I wanted to say about solving other kinds of equations. If you found this video helpful, please consider liking and subscribing. Thanks.